we go. What you'll find is that with functions in general, there are different forms or different ways of expressing those functions, and by doing so, you get different bits of information. And I guess regardless of whether it's a simple linear function or a complicated reciprocal function or something else, every function has critical pieces of information that go to it, key points, I suppose, or critical points. So, for example, for a linear function, the two critical pieces of information about it are what? Gradient for one of them. What's the other one? Someone else give me what the other one is. Gradient and someone else means someone else. Y-intercept is correct. Okay, so gradient and y-intercept. So unsurprisingly, when we have a look at ways of expressing a linear function, they frequently include those two pieces of information. So I'll just zoom out so you can see it all now. So we're going to have a look at three possible forms. These are three common forms of linear functions. The first one is the one that you are probably most familiar with, and that is y is equal to mx plus c. Now, in some textbooks, I don't know if this one is one of them, in some textbooks, they might use b instead of c. So it might be y equals mx plus b. In some textbooks, they might write y equals ax plus b. In some textbooks, or when I say textbooks, YouTube videos, wherever you're getting your source of material from, they might write b plus mx. So a bunch of different ways, but they all have the same property, and that is they have the variable multiplied by a number and then another number added or subtracted to the end. Okay, so we know these already, so very quickly, we know that m is the gradient and we know that c is the y-intercept, and that's why it's called the gradient-intercept form. So examples, y equals, I'll try and give some less obvious examples, I think. So y equals x on 3 minus 2 is an example of that. So m would be, good, 1 over 3. Okay, 1 over 3. That could be written as 1/3 x, and c is negative 2, yeah? It's negative 2. Another example, I'll give you another fractiony one, equals, hang on, I'll go completely crazy. Okay, 8 minus x on 2 is in, it's not perfectly in that format, but it more or less is. So 8 minus x on 2, that means that c is 4, yep, 8 over 2, and m is negative a half, good, okay. So it might be in a weird form, but it basically means it's more or less in that form and could be quickly separated out. The second is this point-intercept form. I'll just do a little bit of theory around it. Oh, no, I'll give it to you first. It's this. It's y minus y1 equals m outside of x minus x1. It's quite a useful version of it because quite frequently you're given certain bits of information. So this time I'll just put a legend instead. So where m is the gradient. Oops. Oh no. I hope it's here. I was next door. It's usually the one next door. Ugh. Okay. So this is useful because if you've got the gradient and you've got any point the line passes through, you can always write down that particular point. If you think about it, I'll just say this really quickly, and if you don't get it, it's okay. I said any point the line passes through, that includes the y-intercept, right? Because if it was the y-intercept, then the y-coordinate would be 0, which would just leave me with y. Sorry, beg your pardon, I'll say that again. The x-coordinate would be 0, which would just leave me with mx. And the y-coordinate would be the y-intercept. If I added it to both sides, I would then get mx plus c, effectively. So any point that the line passes through. Okay, so that's point intercept form. And I'll just write an example and I'll explain where it comes from because it's a really simple reason, a simple way of doing it. So if I said y minus 2 equals 3 outside of x minus 1, I won't write this down, but hopefully my verbal will be enough and you can check back on the video if you need to. This means that this describes the linear equation whose gradient is 3. So it's going upways, reasonable, not really steep, but reasonably steep. And it passes through the point 1, 2. I'll actually just do one more example. Y minus 2 equals a half x plus 1. Okay, that represents the line whose gradient is, yell it out. Wow, so exciting to be in a class where everyone's just pumped to say the answer. A half, that's right. And here's the tricky bit. What's the point that it passes through? I'm going to start picking on people if I'm not careful. Claudia, go for it. Good, -1, 2. Okay, so you've got to reverse the operation sign there to get our point. So -1, 2, thank you. Picked on someone well then. Okay, the general form is, how do I do it? This will do. Sometimes they change the letters, that's why I'm sort of like that. AX plus BY plus C equals 0. That's the general form. So generally speaking, you will find that general forms are when everything is off to the left and you've just got it set equal to 0. Okay, so example, I don't want to belabor this. There we go. A is equal to, thank you, Zoe, 1. B is equal to, other Zoe? Yep, good, thank you, other Zoe. And C is equal to, Arit? Yep. So it might look hidden, but it's there still, okay? I'll just use a more sensible example. Minus 2x minus 3y plus pi equals 0. There we go. Pi is a constant number, right? It represents a very specific value, so it's still okay. Okay, any questions about those? I'm going to go through an example in a second. Rarely is the honest truth. You could be asked to put it into general. So this is one of those things where I'm telling you because it could be in the exam. Guess which one of those three I tend to use? Gradient intercept form. I think it gives you the most information. And, you know, out of the three, it's the gradient intercept form, I think, which allows me to picture it in my head the best. Whereas the other one, the point intercept form, is quick to use. And if I don't need to know the y-intercept, it's quite an easy one to do. But nevertheless, I feel like it's missing a bit of information. And the gradient form requires a bit of mental gymnastics in order to work out what the gradient is and stuff. But all three forms could be asked of you in the exam. Just want to talk about the point intercept form for a second before I look at the example. It's really quite easy to understand where it comes from. It comes from the fact that m is equal to, and then do you remember what we do? We say subtract the two values, or find the difference between two y coordinates, and then subtract the two values of two x coordinates, and that gives me rise over run, which gives me the gradient. So what happens is we know that what that represents is a specific point, oops, x1, y1, and another specific point, x2, y2, like so, right? That's what we know. It doesn't matter whether x2, y2 is down the bottom or at the top. It doesn't matter at all, because if you flip them around, you'll just get a negative over a negative, and that will make it positive anyway. So it's okay whichever order we do it. So what the point intercept form is says, well, imagine instead of this being a fixed point, this could be a point that slides up and down this line here, right? That's basically making it, instead of numbers, it's making it variables, right? And as I slide it up here, the x value changes and the y value changes proportionally, remembering that linear functions are constant proportion. Okay, so in that case, all we're doing really is we're saying, let's make, oops, do it the other way around, sorry. Let's make the x2, y2 pair variables instead of specific points. So we've got y minus y1 over x minus x1. And if I multiply both sides by x minus x1, then that cancels out. And then, of course, I have to do the same thing on this side. And so that gives us m outside of x minus x1, or x sub 1, I should say, equals y minus y sub 1. And then if I reverse, I get that form. Okay, so it literally comes from the gradient formula, that particular form, and by treating one point as a sliding point that can go up and down the line. Any questions on that? Okay, let's get into it. This is just a very simple example. If you're choosing not to write this down, I don't know why, but it's up to you, I suppose. Example, the only example I'll give you before I give you exercise 3D to work on. A linear function has gradient 3 and passes through the point 2, 3. Express in all three forms. Okay, first things first. Which is the most, I've told you which one I like the most. That's the gradient intercept form. But which one can I go to most directly with the information I've got? Is it gradient intercept form, point intercept form, or general form? Which of those three forms, given the information, could I get to straight up? Lily? Yeah, point intercept form. So that's what I'm going to start off with. So we've got y minus the y coordinate, which is 3, equals 3, which is the gradient, x minus the x coordinate, 2. Done. Now, my point with this example here is to show that any linear function can be expressed in any of the three forms, and you can go from one form to any of the other two forms. I could literally choose either form next, but there's one I think makes more sense to go to. What do you think that will be? So you've got a 50-50 now. You don't even have to phone a friend. Yes, you're right. You're absolutely right. Thank you for the audience participation. It is gradient intercept form. Because if I expand it, I get y minus 3 equals 3x minus 6. And if I add 3 to both sides, I get 3x minus 3. I meant to put this heading up the top, but I forgot. So it's gradient intercept form. Is that okay? Do you want to get it into general form, and then I'll catch up in 30 seconds? Oh, I'll tell you one reason why general form is quite good in a second. I just didn't think of that before. As a general rule, by the way, I tend to leave the x term positive. It really doesn't matter. Of course, you can have a negative x term, but I tend to leave the x term positive, which means I'm either taking away y from one side, or I'm adding the negative x term to the other side. So I tend to leave it as positive. Okay, that should be enough time for you to have a crack at that. So you should have written 3x minus y minus 3 is equal to 0 in that order. X then y then constant. Okay. All right, one thing I'll just say, I think it was Zoe that asked the question, when would you use general form? When would it be useful? So I'll just put it as a side note off to the side here. If you had something like y equals a third x plus, I don't know, plus 2, if I multiply everything through by 3, so I'm literally multiplying every single term there by 3, I would get 3y plus x plus 2, sorry, not plus. I'd get 3y equals x plus 6, and then I could write that as x minus 3y plus 6 is equal to 0. So the point there is that general form allows me to remove any fractions from the equation if I'm then trying to do subsequent things with that equation. It's called an equivalent equation, right? An equivalent equation. I'm a bit of a purist, and there's another, I'll just finish on this. I'm a bit of a purist, and there's another reason why I like gradient intercept form, and that is because out of the three, really, in my opinion, gradient intercept form is the only one that writes the equation as a function, because a function should have the dependent variable on the left, and then how to calculate that dependent variable, i.e. the expression with the independent variable on the right. That's how it should work, right? In other words, I put in a value for x, and then I can work out the y coordinate. And the only one that directly gives me that is gradient intercept form. Put in 0, I'll get c. Put in 10, and I'll get, or 9, and I'll get 1, etc. Okay, so gradient intercept form really, in my purest view of things, is the only one that gives it to me directly in function form. I don't know whether I'm alone on that or not. If it doesn't say in the question what form to keep it in, it's up to you, whatever makes sense. But I guess in terms of an exam, if it said write this as, if you got this question, example 1, and you were told a linear function, blah, 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 write down the equation that represents this this scenario. If you wrote that, that's full marks, unless it says gradient intercept form. Point gradient form. Sorry, gradient intercept form. Unless it says that, point intercept form is totally legitimate. So that is clearly much faster to write because it's straight from the information than perhaps substituting into gradient intercept form and then solving for C and then writing it out. So it's well worth being across those three forms just because it might be easier for you to handle, to calculate in the exam. All right, I'm going to put some work up on the whiteboard for you to continue on with after you finish exercise 3C. But does anyone have any questions about what I've gone through today? Okay, while I've got you, I'll just stop the recording because I don't think I need to write